Hello class, my name is Joshua French and I'm pleased to welcome you to the fall 2013 semester of Regression Analysis, Modeling, and Time series. This class is a cross-listed course. It goes by Math 4387 or 5387, the difference being that whether it's an undergraduate or graduate level version of the class. So really this is two classes in one taught at the same time, and we'll talk about some of the distinctions as we look more at the syllabus. My office is CU 611. That's on the 6th floor of the CU Bravo building, across the Spears from the North Classroom building. It's where you'll find me most days of the week. If you need to get a hold of me, one possible way is through the phone, obviously. My office number is listed there, though I would recommend not contacting me that way, as I often forget to check my voicemail, in all honesty. However, I am often on email. I'm there most of the day, so if you need to send me an email, please send me one at joshua.french@ucdenver.edu. We will be using Canvas for hosting most of the course materials for this class, and so if you need to get there, you just need to go to ucdenver.instructure.com and use your UC Denver email username and password, and that will allow you to access the course materials for this course. So we are going to be meeting on Tuesdays and Thursdays from 5 to 6:15 p.m. in North Classroom 2028A. Notice that this is a different classroom than it was originally listed for this class. So I was able to work it out so that we were able to get a different classroom. It's going to be a much better option. The classroom that we're moving into has computers for every single one of the students with the software that we're going to need pre-installed. The previous classroom was just a regular classroom, and it wouldn't have been nearly as good of an experience for you. So thankfully we were able to move it, and that is where we will be meeting starting Tuesday of next week. My office hours are currently scheduled to be Tuesdays and Thursdays from 11 to 12:30 p.m. and by appointment. However, I will say that there is at least a reasonable chance that I'm going to have to switch my office hours down the road. The reason being that I'm teaching another course that the time hasn't been set yet, and so I may need to move the office hours in order to accommodate that class. So this class is actually, I think, one of the best statistics classes that we offer at the university. Regression is really the most applicable, commonly used tool in all of statistics, and so getting an introduction to regression is really a very useful tool if you're going to be doing statistical analysis in some way. And so some of the topics that we're going to be covering include linear and multiple regression, basic experimental design, and one-way analysis of variance. The emphasis in this class is not just on the theory, but also the practical application, and so we're going to do lots of examples that involve data from business engineering, behavioral, biological, and physical sciences. So there are several different fields that we're going to be doing data analysis in. And if I had to describe this course in my own words, I'd really say that what we're going to be doing is learning how to fit regression models. And anytime you do statistical analysis, you're going to be making statistical inference about parameters and making predictions and things of that nature. So we'll learn how to fit the models, then how to make inferences about various aspects of the model. Statistical inference is typically it's always based on some sort of assumptions. And so for the most common types of statistical inference, we'll learn the appropriate assumptions that you need to check, how to check them, how to assess whether the assumptions have been satisfied by our model. And once you recognize that the data fits the model reasonably well, you need to learn how to select the best model. So oftentimes there's actually more than one model that will fit the data set reasonably well, and so we'll learn how to pick a good model. How do we compare models? How do we choose models? After we do that, we are going to learn some basic aspects of experimental design and analysis, and a key aspect of this course is going to be practical statistical inference, practical statistical data analysis using the R statistical software package. There are going to be some proofs required for the course, and some examples of the expected types of proofs well, this is going to be a class. There are going to be some proofs, and you will want to, and we will learn how to do the types of proofs expected in this course as we go throughout the semester. So it's not a proof-based course, for example, compared to something like Math 3000 or Math 4310, but we are going to do some proofs at different times during the semester. And so during class time, we will talk about, we'll go through proofs and examples that will give you the kind of proofs that I'm expecting you to do. So in terms of what I expect of you by the end of the semester, so I do expect you to understand and perform simple and multiple linear regression. I expect to teach you how to do statistical inference for both parameters and responses in regression models. You'll learn how to assess whether regression models satisfy the applicable assumptions, how to determine whether a model is a good model, whether it's a valid model. We'll learn how to model correlated time series data. So we won't spend a lot of time on that, but we will do some analysis involving correlated data. And then after that, we'll do some basic aspects of, learn some basic aspects of experimental design, and then learn how to perform one-way analysis of variance for simple experimental designs. So that's kind of a brief overview of what we're going to be doing and covering in this course. I will say that this course does have some required prerequisites that you're going to want to have. So this is not a first semester statistics class. If you haven't had a statistics class, this class is definitely not the way for you. In fact, you don't just want a statistics class or an introductory statistics class, you want a calculus-based statistics class. Specifically, you're going to want to have taken Math 3800 or Math 4820. Math 3800 is a calculus-based statistics course for engineers that we offer at the university that will provide you what you need to do this course, or even better, if you've had Math 4820 statistics. If you've had that course, then you're definitely going to be prepared to be successful in this course. You're also going to want to have taken linear algebra, Math 3191. Linear algebra is not a massive component of this course, at least not the way that it is taught. But underlying pretty much any regression analysis is going to be some linear algebra. And so familiarity with matrix inverses, matrix multiplication, etc. is going to be very valuable for being successful in this course. Additionally, I would expect that you have some computer programming experience. I'm not expecting you to have taken an entire class necessarily on computer programming, but you should be aware of basic computer programming practices. If you've taken Math 3250, for example, then that would definitely adequately prepare you to be successful in this course. There are some required textbooks or a required textbook that you'll want to get. I list two different options, which may seem kind of odd. But if you look at the authors, you might suspect that perhaps these books are more similar than meets the eye. So the first is Applied Linear Regression Models, 4th edition. The second is Applied Linear Statistical Models, 5th edition. And the first book that is listed is really just the first half of the second book. So the second book listed here, Applied Linear Statistical Models, is really just the first book plus some additional material on experimental design. So if you're a graduate student, and if you have long-term interest in statistics, I recommend getting the second book if you can find it. I was actually told just barely prior to this semester that the second book is now out of print, which was completely surprising to me. Every statistics department in the country, it seemed, used that second book for their introductory regression class, but alas, it appears to be out of print. So if you can get it, that's great. If not, then the first book listed will be completely fine. You don't need to worry about missing out on anything. And I will say that these are required textbooks, truly required textbooks. The homework problems are going to be based on the problems of these texts, so you will want to have it. And I will say also that this is actually a pretty good textbook. It's been around for a long time. It's gone through a lot of editions. They provide a lot of explanations, a lot of examples, and so it's a pretty useful tool to have on your bookshelf when you're trying to learn how to do some aspect of regression analysis. So as I previously mentioned, we will be doing some computing in this class. In fact, that's going to be a very key and essential component of this class. And the program that we use is called R. It's actually a programming language. It's a statistical software environment. And it's really the lingua franca of the statistical community in academia. Basically means that if you're anybody in academia, you're probably using R. It doesn't mean it's necessarily the best in all situations. I'm not going to diss on some of the other options that are available, but R is by far the most common statistical analysis tool that you're going to find in academics. And it's also becoming increasingly popular in industry. So companies like Google, New York Times, they use R. It's free, it's cross-platform, makes beautiful graphics, and it's really easy to extend. So it's really a great tool for statistical analysis. And if you haven't used it before, that's okay. We'll learn it in this class, or at least we'll learn enough to make you dangerous. And I will say that the language is somewhat similar to MATLAB. So if you've used MATLAB before, then you will, I think, feel relatively comfortable with R. There definitely are some differences that will frustrate you at times because you'll want to use MATLAB notation when the R notation is slightly different, but the notation between R and MATLAB is actually quite similar. So you'll be on good footing if you've learned MATLAB. If you want to download R, it's available at www.r-project.org. It's available for Windows, Mac, and Linux machines, as well as some other operating systems. So you shouldn't be able to complain that it's not available for your particular computer. Additionally, it's free, which means that you can download it at no cost. So people put a lot of time and effort into it, but it's available for download at absolutely no cost. And it's also open source. So if you want to implement your own version of R, you can actually do that. People are working on that at the moment. But just downloading the default R version is just fine. Additionally, there is another related tool called RStudio, mentioned down here. And RStudio is really just a tool that sort of adds on to the capabilities of R. It makes it easier to program in some people's minds, allows you to scroll through plots, for example. So some people really like using RStudio to enhance their R experience. You can also download that for free. That's available at www.rstudio.org. I won't probably be using that in class, not because I don't have anything against RStudio. It's actually a very nice piece of software, but the screen is a little bit more cramped, and so when I'm doing analysis in class, I typically like to use the base R for the easiest readability of the students. So in terms of grades, as I mentioned, this is a cross-listed course, and because of that, there are some, some distinctions that you want to be aware of. So homework is going to be one aspect of your grade in this class. I'm going to assign homework about once a week, pretty much for every single chapter, and on the designated day, I expect you to turn a physical paper copy into me. I don't want an email with a PDF or an email with a Word file or some other file, unless I specifically state that. What I want is a physical hard copy of your homework problems. And I will say that unless you have some documented emergency, health, reason, or disability, if you turn the assignment in late, you're not going to get any credit for it. So please make sure that you turn your assignment in on time. When it comes to grading these homework assignments, not every single problem may end up being graded. I might grade as few as one and as many as all of them, depending on what we're going through, my time, etc. Simply because this is going to be a large class. They actually open up this class to more students, so it's usually a large class, but we'll make it work together. I should say though also that the problems that are graded are the only ones that are going to be used to determine your homework grade. So if you do problems 1, 2, and 3, and I grade problems 4, 5, and 6, then you'll get a 0 for that assignment. So you should make sure to do all the homework problems, even though I'm only going to grade likely part of them, and only the homework problems that I grade are going to be used to determine your grade. Quizzes are also going to be another common part of the class. So about once a week we'll have a quiz, possibly unannounced, though typically I do try to give you an idea of what to expect beforehand. So I'm interested not in rote memorization, not in our arcane little details of statistical analysis or regression modeling, but big picture questions that if I stop you down the street 3 years from now, you will hopefully be able to answer because they're big picture questions. And as with the homework, unless you let me know ahead of time or you have some emergency illness or disability that I'm aware of, then any missed quizzes will be scored as a zero. So please make sure to show up to class on time, take the quizzes when necessary. There are going to be a couple of exams during this semester. The first exam is going to be on Thursday, September 27th. The second on Thursday, November 15th, almost right before, I guess about a week before Thanksgiving break. And exam due dates are fixed. So everything else in the syllabus is free to fluctuate a little bit, but the exam dates are fixed. And similar to the homework and the quizzes, unless I know ahead of time that you're going to miss an exam, or unless there's some documented health, disability, or emergency, if you miss an exam, you're going to get a zero. So please make sure you show up to the exams on time and work hard to be successful. One thing that is nice about this class is that we will not have a final exam. It's just really too difficult to cover all the material in the semester in one short exam. And so instead we have a final project. And all students are expected to complete the final project, but undergraduate students will be able to work in groups of some designated size, which we'll determine later depending on how many people are in the class, while graduate students are going to have to complete their project individually. And in this project, you're going to have to analyze the data set of interest, describe your results in some formal paper, and then also present your results to the class in a short presentation during the time scheduled for the final exam. So this is not something where you're going to take the whole class. The presentation is usually something like 10 minutes, but it's worth 20% of your grade, as we'll talk about shortly. So it's something you want to take seriously. So Math 5387 students, the students who are taking this class as a graduate level class. You may also be assigned extra homework and exam problems, or have more difficult exam problems, more difficult homework problems. It's a graduate level class, so expect to have to work a little bit harder than the undergraduate students. And when explicitly stated, the Math 4387 students can also do these problems for extra credit. However, if I don't say it, then don't do these problems, because you won't get any benefit from them. You won't get any grade benefit from them. You may get moral benefit, I suppose, or learning benefit, but you're not going to improve your grade at all. So in terms of the grading scheme, I use the weighted grading scheme. So your quizzes are worth 10% of your grade, homework is worth 20% of your grade, your final project is worth 20%, and then each of your exams is worth 25% of your grade. So all the different components of the course, all the different types of assignment are pretty important in determining your final grade. The letter grades are determined according to this scale right here, which is really pretty much the common scale, except that there is no C minus. So anything between 70 and 78 is going to be a C. But because there are no C minuses, the 70% is very strict. So if you have a 69.9%, do not expect to get a C, expect to get a D+. If you want to get a passing grade in this class, you need to get a 70%. And I'll make your grades available via the course's Canvas course shell. So anytime you want to look at your grades, after I've posted them, simply log into Canvas and look at the Canvas gradebook. And in terms of how I'm going to return your homework, quizzes, and exams, I'll typically return those in class, but if you stop by my office, I will also be willing to return that to you directly, but I won't give them to your friends or anything like that. It's got to be returned directly to you. Something that is very important in this class is being honest. So basically, don't cheat, don't plagiarize, don't use your neighbor's work inappropriately, I guess. It's certainly fine on homework assignments for you to talk and work together. I mean, that really is a valuable part of the learning process. But the work that you actually turn in should be your own. It shouldn't look exactly like the homework or have the exact same answer that your neighbor does. It should really be your own work in your own words, in your own, explained in your own way. That's going to be what's best for you in terms of learning the course material, and it will also protect you from being charged with some sort of academic dishonesty. And definitely do not get help on a quiz or an exam unless I say it's okay. If you do, if you get caught, I'm going to turn you in, and that's just going to be embarrassing for you. It's going to be awkward for me, and so please don't make me do that. Please just be honest. And if you have more questions, then see the academic honesty handbook, which there's a link provided later in this syllabus. If you have some sort of disability that needs to be accommodated, I'm completely happy to provide you with whatever accommodations the university deems necessary and appropriate. However, in order to receive these accommodations, you do have to go through the Disability Resources and Services group on campus. If you don't go through them, then I can't provide you with any kind of accommodation whatsoever. But as long as you go through them and they provide me with an email or a piece of paper stating exactly what accommodations you need to be provided, then I'm completely happy to provide you with whatever they ask me to. I do expect you guys all to abide by the UCD Student Code of Conduct, so please look at that. The document is also linked later in the syllabus. I'll just reemphasize this one more time just so that we're completely on the same page. Please don't be absent, please don't be tardy. If you are late for an exam, if you're late for a quiz, if you're late and you don't turn in a homework assignment because you're late, or if you just simply miss those things, you're going to get a 0. So unless there's documented illness, documented disability, documented health issue, documented emergency, or you provide, unless I approve it ahead of time, don't expect to receive any sort of credit for late homework assignments, quizzes, or exams. So please be on time to class, please do all your work, turn it all in at the designated times. So some expectations and some, I guess, comments about success. So first, this is a senior level / graduate level class. It's 4,000 level class, 5,000 level class. That means you should expect to work hard, expect to work 6 to 9 hours per homework assignment, expect to study for an hour or two for your quizzes, expect to study multiple hours for your exams. This is not going to be an easy course. I do believe it's going to be a rewarding and fulfilling course, and that you will leave here feeling like you learned valuable tools and ideas that you can use in real life, but you're going to have to work in order to be successful in this class. And one thing that will go a long way toward being successful is attending and participating in class. If you're not in class, you're not going to learn what I have to say. There's something about being in class that just helps bring you in the loop and encourages you to ask questions, seek help, etc. So please make sure that you come to class on time and whenever you can. I also expect you to participate. So if you have a question, if you have a comment, if you need help, please let me know. It's really no bother. It's not I love to get questions. I am definitely not the best communicator. There's always room for improvement. There's going to be times when I fail to communicate something clearly. I make an error. I might say one thing and write another, and that needs to be corrected. If you have a question, if you think I made a mistake, please raise your hand. Let's talk about it. Let's work through it. I want you to be successful, but I can't help you if I don't know that you need help. So please ask questions during class, or if you don't feel comfortable, then feel free to ask during office hours. I'm definitely happy to meet with you outside of class if necessary in order to help you understand the concepts and tools of the class. I do expect you to read the relevant sections of the book. The book is going to provide a lot more examples, provide a lot more detail than I'm typically able to provide, and so that will also help you to be successful. And preferably, you should read the material before the lectures. If you don't, I understand, but one way or another, I would strongly encourage you to read the book because it's going to help you to be successful in this class. Another tip that I suggest for helping you to be successful in this class is to make sure that you complete the homework as the homework sets are assigned. What I mean is, don't wait until the last minute to do your homework and turn it in. Certainly, it's better to turn it in right before the deadline than to not turn it in at all. But if you really want to get the maximum benefit out of the homework, then you really should start the homework assignment shortly after it's assigned, work through it slowly, confidently, and that way if you have any questions, you can talk to me, you can talk with your classmates, and it really just helps you to retain the information that much better. If you're rushing through things, you're liable to make mistakes, you're probably not processing and really retaining the memory of what you've done, you're just trying to get a grade, and that's not going to help you in the long run. Course announcements are often made via Canvas and or email, or perhaps both. So make sure you're checking your Canvas frequently, make sure you're checking your email frequently. This is really the primary way that I communicate with you. If I forget to say something in class, but I've announced it via email or on the Canvas announcements, you're still going to be responsible for that material. So don't expect me to say everything in class. I do try to say everything in class. I always try to repeat what I announce, but there may be a time when I forget. And so make sure that you check these things, because you are responsible for the information provided on Canvas and for the information provided through your email. And of course, please turn off or silence your cell phones during class. That can be very distracting. And lastly, if you have a conflict between our class due to some religious observance, then please let me know. I'm happy to accommodate you in whatever way the university would like me to, but I need to know about it ahead of time. So please don't just miss class without letting me know. Please just let me know, and I can work to accommodate you. Another piece of information that I should make you aware of is student grievances. So if for whatever reason you do have a complaint about me or about the course, then there are a few steps that you should take. So first is to come talk to me. So hopefully I come off as an amiable and approachable guy. I guess if not, the university still requires you to come talk to me if you have concerns about the course or about me. I'm happy to listen to you. I truly want to make this the best course possible. So if you have a complaint, if you have a question, if you think that things can be run better, then please come talk to me. I'm happy to hear what you have to say, and hopefully I can work and modify the class to accommodate you in some better way. If you're not satisfied with that experience or the way that I respond to your thoughts, then you should meet with, first of all, or primarily, Steve Billups, who's the associate chair in the department, or Jan Mandel, who is the chair. And if you aren't satisfied with the service either of those two gentlemen provide you, then you can appeal to the associate dean. However, I will say that no step in this process may be skipped. You can't go to the associate chair without going to me first. You can't go to the chair without coming to me first. You can't go to the associate dean without talking to me in the chair. So this is in accordance with the College of Liberal Arts and Sciences. This is not something that I made up. This is the college policy. Some university-wide policies that might be helpful to be aware of are provided at the links right here. Their student code of conduct, various accommodations, academic freedom, FERPA, attendance, discrimination, grade appeals, etc. So lots of information if you care to look it over. This syllabus should be pretty close to finalized, but it's possible that I might have to add a sentence or two, might have to change some things, might have to change the schedule, whatever. I reserve the right to do that. So I don't like to do that. I don't take that lightly, but at some point I may need to modify the syllabus depending on the circumstances. So the tentative course schedule is outlined on page 6 here. This could change. So we may go faster, we may go a little bit slower. I expect this to be a pretty good indicator of what we're going to do and when we're going to do it in the course. But just be aware that these things could slide, these things could change. The only thing that's really set in stone, I suppose, are the 2 exam dates, though the material on them could change depending on what we actually end up covering, and the fall break, of course. So that's not going to change. There are some college policies on page 7 that you might want to be aware of in terms of email, wait lists, adding and dropping classes, tuition, etc., as well as some important deadlines and days that you want to be aware of. So I'm not going to be reminding you of these throughout the semester. These are your responsibility, but they are provided in the syllabus for your benefit. If you have any questions about the syllabus, about how things are going to work in this course, please don't hesitate to contact me via email, or we can set up a time to talk over the phone if that's preferable. Or I'd be happy to, well, I will definitely take questions on Tuesday of class next week if you have anything that you'd like to talk about at that time. Hope you guys have a great evening, and I look forward to meeting you all soon in person.